So hi, I'm Dor. I'm here to speak about DevOps-friendly databases. Practically, I'm not going to talk about any specific database, even the one that my company manufactures. I can say, like, honestly, the one that we manufacture doesn't, of course, apply to all of the good properties that I'm going to detail here. So the idea is to bring up to the surface a lot of properties that a good database should follow and should be practically serve you as a DevOps in your day-to-day lives. So that's the idea. And before we get into talking about databases, let's talk about what's DevOps must have in general. It's of course natural to think about what's good for your own application running a DevOps, but maybe database in that aspect is a bit different because it's more of a software component that doesn't move as fast as a regular application. So of course, always on, 24/7, and multi-zone, and all the things related to that. And automation-friendly databases should be automated, of course, especially in this era where everything is scalable and elastic. Now, the main thing that you would want from your database is to have no fear in changing your environment. That's the main thing because it's also related to automation. If you have good automation, then the risk of change becomes lower. If you don't have it, then of course the risk is huge and you shouldn't do anything. So practically the whole idea is to decrease the fear, and the fear decreases by good properties of the database and your environment, of course. So of course, everybody do git push, and that's normally not the case for putting updates on your schemas, but it is possible to do, but you of course don't look and see if it fails. You try to have some infrastructure in place to prevent that. So basically, most of the talk is how to try to improve upgrades and to cope with situations in the field. And of course, the risk should be capped. Also, upgrades are simple. Downgrades aren't necessarily as simple as that. Some products support rolling upgrades, recent ones, but with downgrades, that's harder. Who knows what's the best way to downgrade any software component? So it's a clue. It's related to Git, or it's the best. I would say it's the best practice that mostly this path is mostly never taken. But with Git, when you push a commit and you need to push it back, you don't reset to the previous head unless it's your own development environment. What usually is a good practice is to commit a revert. So with a downgrade, if a good database or a good software product allows that, the best thing is to upgrade to the previous version. So that'll be a fantastic practice, of course. I don't know if there is a tool out there that supports it, but that's definitely an interesting aspect to downgrades. And I think that you'll agree with me that it reduces the amount of paths and reduces the friction. So I think that's the right way to go. And one last and important thing is to prevent silos. Sometimes silos are a good thing, especially if you have lots of regulations or things like that. But normally, silos are a bad thing. It creates proliferation of services. It creates legacy islands. So it's a bad thing, and you should prevent that. Also, the same case goes with your database. I won't going to cover and I won't going to compare Cassandra to Mongo to MySQL, and so I'm going to skip over that. But do know that I work for a company called ScyllaDB, and you'll need to pronounce it right at the end of the session. And just to put things on here, because I'll be talking about performance. Our idea is a re-implementation of Cassandra from scratch that provides you all of the good properties of Cassandra with the speed of Redis, actually a bit faster. But that's for Scylla. So I'm going to mention 10 things which makes a database DevOps friendly. There are, of course, more than 10 things. So in the first one, I put just straightforward things. So, and I merge several things that are unrelated. So we'll quickly move into the more interesting stuff. So, of course, security and multi-platform and audits and logs, etc., are super important. Nice thing about to notice with regard to security is that encryption between the clients and between the nodes is straightforward. Of course, not everybody needs that within your own private LAN, but there are some that do need it. When you do need it, it's important to manage the keys correctly, because that's something that many will fall. So pay attention to this, and there are products out there that do manage the keys. Normally, it's an add-on to your database. So let's move into more interesting stuff like backup and restore. So, of course, that's trivial. I think that's why S3 was invented, in order to do backup and restore. But is that really the case with modern databases? So I don't think so. What's the problem? The problem that modern databases are eventually consistent. So if you're eventually consistent on your day-to-day transactions, then certainly you'll be eventually consistent when you take a snapshot of your database. Even taking a snapshot of the database is super hard because it's distributed and contain dozens or hundreds of nodes, and that's also a nightmare to manage. So most products today out there just do some type of local node snapshots, and within that snapshot, you get to keep all of the data from all of the replicas, and of course the data is eventually inconsistent or temporal inconsistency within your snapshot, and you need to be aware of that. Just I jumped one thing too quick. All right. So is that totally wrong, or is that a bad thing to snapshot and to back up eventually consistent data? That's the right answer, actually. So it depends, because if that's what you'd like to do, and if your application or the database that restores from this eventually consistent data knows that and knows how to cope with that, and you won't modify the eventually consistent algorithm, then it can be totally fine, and that's fine. But if it's not the case, and you'd like to take the snapshot and move it into some offline analytics processing, and you really rely on the data, that's a problem. So make sure you know what you do when you take a distributed eventual consistent snapshot. And I would say that what's desirable is that database vendors will not only offer regular snapshots or a single node snapshots, which can be consistent even for let's say MySQL, but once you're distributed, then it's really a super hard task. It's still possible, and I wonder actually in this room whether is there a demand for such a snapshot, or maybe it's like too far-fetched and most people are good with eventual consistent snapshots. Or most people just hope that their backup one day will be usable, and that's the restore path. So mostly when you restore, you're just happy. If it's worked, then wonderful. But the problem with sophisticated infrastructure is that you're going to restore not necessarily on the same piece of hardware that you took the snapshot. Usually it means that you support multi-zone, so it will work on a different scenario with different IPs and potentially different environment. Another thing is you may want to restore on a different set of hardware, a different number of servers. Especially if you'd like to even upgrade your environment. And that's a challenge because if you took the snapshot and the snapshot was taken per server with all of the sharding in place, now you need to modify it on a boot time. That's really challenging. So good tools need to cope with that. Another thing is scale. There are mainly two things with scale: scaling up and scaling out. So I call anything below 50,000 ops operation per second quite poor scaling. And with today's computer, with dozens of cores, 10 gigabit networks, even now the Mellanox came with 100 gigabits per networks per second. NVMe drives, there's no reason in the world why you should be satisfied with a few thousands or dozens of thousands of ops. Usually the problem is that, of course, hardware is cheap, you can buy more, and labor is expensive. So, all right, I'll throw more horsepower at the problem, and it will just take care for itself. The problem is that the more your cluster gets bigger, then the more problems appear on the surface, and the more edge cases that show up, especially in distributed systems. And the mean time between failure is constant for the hardware. So the more hardware you get, let's say you keep consistently replication factor of 3, then you'll get real problems, and even data loss if your cluster grows and grows indefinitely. So take that in mind. Was there a question or just an itch? Another thing is, Reed, the guy from the keynotes, talked about mechanical sympathy or engineering beauty, and if the system can't perform, it means that it's engineered poorly. So probably there are other cases within the product that aren't as good. So usually, sometimes people say that they're going to develop fast and ignore performance in early stages, but I'm pretty sure that they ignore a bunch of other things. One additional thing for database is if it's slow, then you plant a cache in front of it in the form of memcache and Redis, but that's another set of complexity, and now you need to make sure that these caches are coherent, and of course another set of cluster to manage. So good databases do not need a cache. Good databases employ a cache of themselves, and actually if you save the external cache, then you can apply all of the RAM from that setup. First, there's no labor in managing it. There's no labor in keeping the cache consistent. And of course, you can move the RAM from the cache into your database and get even better performance. And lastly, many times people use NoSQL as really plain key value, and just planned instead of using wide rows or nested data, they just use it as one big blob, which can work, of course, but then why would you use a database? Go ahead and use a simple key value like Redis and Memcache if you do not need a database. If you do need a database, you would like to use all of the good properties of the database like maps and indexes and all of these things. But of course, they come with a cost. So the lower you begin, then it will only degrade from that point. Second thing is scaling out, and no matter how strong your performance is, you need to scale out. First, you got to take care for high availability and fault tolerance, so that's a must-have regardless of your performance. And beyond that, still every system can get to its needs, so you do need to scale out. If you do scale out, it's really good to keep it symmetric. Of course, I'm not even talking about single point of failures, but keep that symmetric, so you wouldn't need to create like a ratio of 3:1 with some sort of a directory or naming service and other services, because then you'll have areas of either lots of inefficiency or bottlenecks. Now the book scale out is just a linear graph with some factor, but that's what normally you have in the books or in very nice benchmarks. But in real life, you get this messy picture. So, any guesses what we try to achieve with this fantastic graph? No, it's with garbage collector. It should get down eventually. Huh? So these are ops, and that's over time. And over time, we added nodes. It's a Cassandra cluster that started with 2 nodes, and we hit it with as many clients as possible to check the throughput and check the effect of adding nodes every couple of minutes. So the idea is to let the cluster get to a consistent state, and every 2 minutes or so we added a node. The existing nodes had to synchronize the new node, and then the performance improved a bit. But in each point in the way, there was a huge drop when we added that node, and the existing node had to synchronize the new ones. So it's quite a horrible graph, and we were really surprised with this behavior. We tested it over and over again. We have a Git project with Ansible for testing these type of things. It's open source, by the way, and can test whatever you like, so you're welcome to use it. But eventually that's the pattern we got, and of course it's pretty bad. So if you do take a database for a test drive, test its scale-up abilities. And I think that's mostly the reason that most people have a static infrastructure and not fully elastic auto-scale, which is one of the requirements for a really good database or overall application. Eventually, eventually we stopped. So it is possible to add nodes, but the pattern was identified and it was enough for us. It wasn't too big, so I assume that the bigger the data set, then that's true. And with this tool of ours, then it's also possible to set the period of adding nodes and the data set as well. consistent tail latency so of course low latency is important, but tail latency is way more important than average latency and of course, if your infrastructure is implemented using Java, then you're going to suffer from GC in one point or the other, and it will make you pay for it. Sometimes you pay in your time. Sometimes you may go to Azure, for example. This graph is taken from Azure and compares Azure garbage collector and JVM versus Oracle. And that compares either that's the maximum latency in milliseconds. So there's more than 100 milliseconds. I'm sorry, there's more than 500 milliseconds, half a second with Oracle, and much less with Azure. Very, very impressive. What they don't show you here is how much time. All right. I'm good in speeding up things, so I'll speed that up. So what they don't show you here is that Azure are fantastic in terms of latency. Of course, C++ will do better than that, good implementation, but it comes on the expense of throughput. So that's one of their magics in here. A really cool thing, phenomenal about latency and tail latency is coordinated emission, because if all of the events come one after the other and they're not parallel, then if you have an outlier like the first graph, then all right, one or few requests got hit and that's it. But a field experiment will actually cause all of the parallel requests to slow down as well. So the actual graph will look like this, and more percentiles will be hurt by it. Okay. So automation. So databases or any good other product should take care for its own configuration, whether it's garbage collection or OS tunables, like the number of huge pages and the number of open files and any buffer sizes and all. The database, or if you develop an application, your application needs to take care of it. Don't throw it on the user, because it's horrible. The number of options just explodes, and eventually in Oracle, in Java 1 world, they opened their talk by saying, try to rerun your application without all of the GC flags that you added over the years. Normally, there are more conflicting flags in your very same command line. So tunables are pretty notorious, and vendors should take care to come with their best defaults, and that's it. Another thing is elasticity. So auto-scaling is important, as I showed before. It's pretty saddened to see that sometimes with a lot of products, for instance, Cassandra, and also the same database that we manufacture, suffer from the same thing, is you can't automatically join many nodes to an existing cluster. Like if you have a cluster of, let's say, 10 nodes and you want to grow it to 20, you cannot do it immediately at once, like boom, add another 10 nodes and let the database take care for itself. Who knows why? Or what's the excuse? There's no real excuse for it, but why vendors choose to throw this on you as a user? I'm sorry? Sequence? The sequence is less important. The main issue that it's consistency, because if you had a 10-node cluster and now you're going to have 20, there will be a moment in time that you lose the majority. And if the database is eventually consistent, you need to manage an internal majority and the consistency. But really it's an excuse. A good database should manage it and not necessarily promote all of the nodes at once. But instead of you making the automation for them, then that's the vendor who needs to do the automation for you. Another interesting stuff that we discovered on our database journey is that normally database vendors expect the user to run repair, ongoing compaction or major compaction. It all needs to be automatically scheduled by the database itself and should come out of the box, not throw it on the user. Sometimes it gets thrown on the user because the database itself is bottlenecks and it cannot serve requests as, in parallel to do regular maintenance jobs, which may trigger excessive IOs. But it's just an excuse. Good database should do it all by itself. And of course, sharding, that's another good properties of a database. If you manage database by yourself, like MySQL, for instance, then you need to do your own sharding. But sharding is hard, especially resharding. There are solutions and there are virtual nodes for that, but that's quite a pain, and it should come out of the box from the database vendor. Extensibility, that's of course obvious. You want to import and export in the format you like, and the common ones, no need to that everyone will redo all of the things. That's the case for user-defined function scripts as well. Lastly, or mainly the most important thing about this bullet is building blocks. So database shouldn't be one-trick pony. Database needs to be an infrastructure. That's the base case when you choose a database. Try to choose one that will serve lots of usage within your expected patterns, and will be able to run things like time series and graph databases and plenty of other things on the very same infrastructure. If you get that's a success, no matter what database you picked. So who knows, call me maybe. Who knows a database that passes Kyle's test? Which is it? Zookeeper. Mm-hmm. That's one. How many databases do you know overall?
Probably like 25 or something.
Mm-hmm. Yeah, that's pretty sad situation where one tool manages to pass it, and that's a wonderful tool. Whether if you're going to test a Zookeeper or some other infrastructure, I strongly urge you to go ahead and redo all of the tests and ask yourself the questions when you develop your own application, because probably it's clustered, it's distributed, so it's worthwhile to look into other people's solution or other people's tests, not necessarily solutions, because only one manages to pass it. Well, that's basics, that your database needs to be integrated with Hadoop and Spark and good tools for analytics. But it's also shouldn't. And the idea is that your database should be self-contained. So all of these tools are great, but what if your database can do most of the work for you? Then it'll definitely be more simple if you won't need to grab your analytics experts, and we'll be able to do aggregation on the database level, and that definitely will going to be faster than anything out there in the market using Spark, because the aggregations are done in the database layer closer to the data, and data doesn't need to pass between the different clusters. Another wishful feature that I have is a test and dev environment. So some do have, but what I'm aiming here is that your database, or the way you built your database, so it doesn't necessarily means that the database vendor needs to provide it, although I think it would be a great thing. It can come up with the tools that wrap the database. Think for instance that if you could have an environment where you proxy and duplicate all of the requests that come to the database to a neighboring environment that will be friendly for test and dev, then using the same real-life patterns and the same real-life data, you'll be able to test your own application on the live data without damaging the real data. If you'll just clone either, sometimes you can do it in the client level and just have the client send duplicate writes to the database and to a new test and dev environment. But of course, that forces you to change the client, and that's complicated. It would have been perfect if it could have been done either in the database layer or the tools that wrap the database.
It could be argued that it's not really practical because the strategies that you need for kind of spinning off that data stream involve things like sampling, which has consistency constraints, anonymization, security issues. Like, there is no general purpose solution for this. It's application specific.
Well, it's not necessarily. You can authenticate in a different manner. You can make it more complex. The question is, how common is that? And like sampling, it is possible to do it like without sampling. Just clone the entire traffic. And normally, it shouldn't be a problem with the regular levels of resource utilization. But it's not necessarily out of the box, but it may fit one organization and not the other. Opa, I revealed the number one. Yeah, and I'm about to finish. Number two, which really is a holy grail, is multi-tenancy in the database level. So things like microservices push us to create more and more services, and these services needs a database. So you find yourself running more and more databases, more and more clusters, and each of the clusters needs to have its own high availability and multi-zoning, et cetera, et cetera. So there's a lot of idle time and resource waste lies in all of these multiple clusters, and of course a lot of administration time that goes into managing those multiple clusters. And you also going to have silos of really old versions that no one touches, and it's really a bad situation. The reason that people get to this situation is because most of the databases out there can provide really good SLAs between the different potential tenants. So you can define key spaces and tables, that's not a problem. But if you have an analytics offline batch processing and a real-time requirements for some other service with under 1 millisecond requirements, these things will going to clash, and that's why things happen like this. Really a desirable thing is to support multi-tenancy in the database layer and to define SLA per tenant, and this way, pretty much, if you're familiar with DynamoDB on AWS, pretty much bring the SLA to the contract with the user and actually make it some sort of a SaaS. So even though you may be running this database within your organization, only one administrator is needed for the real database, and for the tenants, they just need to supply the SLA and need to eventually pay for the service that and need to be charged. So that's desirable, but an implementation for that is, if you're familiar with resource group from containers and Docker world, then a good implementation for that will define the level of RAM that you allocate for a tenant, the number of IOPS, the number of network packets that you allow for the tenants, etc., or in the number of of the volume that you allocate for it. But basically, once you take care for all of these, you're going to have a fantastic system. These systems, I think, other than Oracle, no one else offer them. We don't offer them too, but we will in the future get to this scenario. And lastly, open. I think openness is the key for everything. And I'm talking about, it could be either open source or fantastic open APIs. It doesn't necessarily has to be open source, but open source has a lot of value because all of the code is out there. Sometimes there are great products with really good APIs, and that should be pretty sufficient for your need. That's a must-have, because with these tools you'll be able to automate and reduce your risk to your environment. And now we probably have 2 minutes for Q&A. So I definitely agree. Would you like to share like a wishful thinking, or provide an example for a client that does better job than others? I definitely agree. Anything else? We're done. Sharp on time. Thank you very much.
Thank you, Dor.